Let's take a look at questions 11 through 14 on the practice quiz. It says, a certain street has a posted speed limit of 30 miles per hour. A random sample of 21 cars were observed and had their speeds measured. The average speed of the selected cars was 32.1 miles per hour with a standard deviation of 4.2 miles per hour. The following questions are about a 90% confidence interval. Okay, so let's just do a quick review. Here we are dealing with a numeric variable again, which is the speed of the car. And we have taken only one sample of 21 cars. So we have one sample here. So numeric variable, one sample. And the questions say we're going to deal with a confidence interval. So for a confidence interval, the formula that we use is going to be x bar plus or minus t star times the standard error. And the standard error is equal to s over the square root of n. Okay, so the first question says, what is the t star, or what is our critical value? Okay, so our critical value, t star, is going to depend on our 90% confidence level and our degrees of freedom, which is equal to n minus 1. So if we read the problem, it says I've selected 21 cars, so that means I'm going to have 21 minus 1, I'm going to have 20 degrees of freedom. So let's go to our table, look up 90% confidence, 20 degrees of freedom. 20 degrees of freedom, 90% confidence. So 90% confidence is our second column. 20 degrees of freedom, I'm going to use 1.725. That's going to be my t star. So t star is equal to 1.725. Let's take a look at our answer choices. Indeed, we see answer choice E is 1.725. For a 90% confidence interval, what is the standard error? All right, so our standard error is just going to be s over the square root of n. So our standard error, s over the square root of n. So let's look at our problem and pick out what s and n are. S is the standard deviation of my sample. N is my sample size. So it says we took a sample of 21 cars. So my n is 21. And my standard deviation of the sample says with a standard deviation of 4.2. So my s is 4.2. So I'm going to have 4.2 divided by the square root of 21. Let's punch that in and see what we get. 4.2 divided by the square root of 21. I get 0.9165. 0.9165. And looking at our answer choices, we see answer choice D is 0.9165. Number 13 asks, what is the upper bound of the confidence interval? Okay, so our confidence interval will have an upper and a lower bound. So the upper is x bar plus t star times the standard error, and the lower bound is x bar minus t star times our standard error. Okay, so we've already calculated our standard error, 4.2 divided by the square root of 21. So I'm going to multiply that by t star, which we've established as 1.725. Okay, so I get t times the standard error to be 1.58098. So I'm just going to round off to 1.581. 1.5810, and x bar is the mean of our sample. The mean of our sample is 32.1. Okay, so I'm going to use x bar 32.1 plus 1.5810. So we're going to add 32.1 to that, and I get 33.6810. 33.681. Okay, and just for completeness, I'm going to do 32.1 minus, this product's going to be the same, 1.5810. So let's do that, 32.1 minus 1.581, and I get 30.519. Okay, so anyway, the question was asking what is our upper bound, and we have 33.681. So let's take a look. Oh, it actually keeps more decimals, but answer choice D is the closest thing we have. Actually, all of the other ones are way off. So 33.6807, that seems close enough to me. Okay, and number 14, does the confidence interval provide evidence that the population mean is different from 30? Well, let's take a look at our interval. Our interval goes from 30.519 to 33.681. And we want to know, does this provide evidence that it's different from 30? So is 30 within our interval? 30 is not between these two numbers. So 30 is not between the ends of the interval. So that means we have evidence that the average speed is different from 30. So let's take a look at our choices. Okay. So does the confidence interval provide evidence that the population mean is different from 30? Yes. 30 is not within our interval. So this provides evidence that the population mean is different. So answer choice B is the one we want. Okay. And there we have it. Hope this has been